Okay, so let's just do a quick warm up here. Find the missing angle. Well, there's nothing there, so we're going to do a little writing of our own. And we are going to add an angle, and we can call it A if we like. So we would say A plus the 32 plus the 90 equals 180 degrees. So A plus 122 equals 180. Subtract the 122 from both sides, and A is equal to 58 degrees. Okay, so we're going to move into interior and exterior angles today in polygons. So by the end of today, I'll be able to determine the sum of the interior inside angles. Now we've already done that with triangles, but we're going to extend it to polygons, which is just a multi-sided closed figure, and I will be able to sum the exterior outside angles of polygons. Okay, so we're going to start with a quick little proof here. So if we start with a triangle and we say the number of sides, we could say that's 3. The sum of the interior angles, that's 180 degrees. We have a sketch, and the number of triangles you see here is 1. Okay, so then we're going to move to our next shape, and maybe I'll just change the zoom here so we can see a little bit more. Okay, now I have a quadrilateral, and what I'm going to do with the quadrilateral is I'm going to actually chop it. So I'm going to go from a corner to corner, or vertex to vertice, and now you can see I have 2 triangles. So this would be 2 triangles. So now each triangle, though, has 180 degrees as the interior angles. So if we sum that up, we have 2 triangles, 180 each. This becomes 360 degrees, and the number of sides is 4. Okay, so let's keep going with that thought, and you'll start to see a pattern emerge here. If we go to a pentagon, 5 sides, and I'm going to start here and make triangles. I don't want any of my lines to cross. And you can see, whoops, I have 3 triangles. Now 3 triangles at 180 degrees each would be 540 degrees would be the interior angles, the sum of the interior angles for a pentagon. Okay, let's move to a hexagon, 6-sided figure. So we have 6 sides. Let's start here and I'll draw. So you'll notice I'm not crossing any lines. I just pick a corner and then I go to all the other corners. And if we count them up, there are 4 triangles. Okay, and if each triangle provides 180 degrees to the interior angles, then this becomes 720 degrees. Now you're probably starting to get the idea here. A heptagon, let's get rid of that thing on the bottom there. So we'll do heptagon, octagon, and then eventually we're going to do an entagon, which will be some unknown number. So a heptagon, 7 sides. 7. If we draw triangles, so we'll start here to here. 1, 2, 3, 4, and 5 triangles. They each provide 180 degrees. So a heptagon would have an interior angle summation of 900 degrees. And then lastly, an octagon, and hopefully you're seeing the pattern here. We cut these up, and we should have 6 triangles, and 6 triangles all providing 180 degrees of interior angle. This should be 10 or 1080. Whoa, stop. Let's back that up. 1080. Okay, now let's move to an entagon. The number of sides, n. Can't draw the picture because it's got an unknown number of sides. What I can start to see though is, hey look, 6, 4, 7, 5. See a pattern here? Okay, so what we see is that the number of triangles inside is n minus 2. Okay, well to get this number, the interior angles, this was 6 times 180, and that 6 came from over here. This was 5 times 180, 4 times 180. So to get my entagon, I would have to take the number of triangles, which is n minus 2, and times it by 180 degrees. So if you had a 20-sided figure, you would simply put n is 20, subtract 2 from it, multiply it by 180, and that would give you your interior angles. So let's do one. What is the value of the unknown angle, this little horseshoe or omega, for the following? Well, if we look at this, this is a 1, 2, 3, 4, 5, 6-sided figure. So we could do this a couple ways. We could take our expression that we just proved. We could put a 6 in here, and we would have 4 times 180, which is 720 degrees, is the interior angles, but we have 6 horseshoes, so we would have to take our horseshoes and set them all equal to 720, divide both sides by 6, and you get 120 degrees would be each one of these angles right here. If that makes sense. If you can't remember the formula, that's not a big deal either. You just chop it up. 1, 2, 3, 4 triangles. That would jump you in on that line. 4 triangles with 180 degrees. You could still solve the problem. That's interior angles. That's all there is to it. Okay, exterior angles are created by extending the sides beyond the shape. So let's see if we can just go back to our proper zoom. So if you were to take this and recognize this is a supplementary angle, you could put in 70 degrees here. You might also notice this is a parallelogram, so we could fill in some of the missing information. Okay, and this would be 70 from co-interior. Okay, and now if you took a highlighter and you highlighted all of those exterior angles. An exterior angle is on the outside of the shape. Okay, and if you highlighted all of those and then you added them all up, let's go back to a pen, you would have 110, 110, 70, 70, and if you add all of those together, you get, wow, 360 degrees, which you might think, that's just fluky. Well, let's take a quick look at Geometer's Sketchpad. Come on, fit within my window. There we are. Let's see if we can get this side down. Perfect. So let's go. This is interior. So if we look at the interior for a 4-sided figure, you can see how it's 360, and we already proved that one. You can drag that around. Let's try and switch over to, here's exterior. So now I can move these guys around. Come on, move. Oops, no, let's try this one. Come on, Zed. Let's get the mouse going here. Come on, Zed. Nope, not going to move. D will move. And you'll notice the 3 exterior are the exterior angles, all sum for 360 degrees, no matter where I put them. Okay? Now, what is the sum of all exterior angles on different polygons? So let's get rid of this Geometer Sketchpad here, and we'll open a new one. This is a fun one. I really like this one. So if we looked at this shape, so this is a pentagon, you could see the exterior angles. If you shrink it, all of those exterior angles come back to form a circle, which means the exterior angles form a 360 degrees. Well, you might say, well, that was just fluke. 4 and 5-sided figures are the same. Well, we could add a bunch of, let's go to an 8-sided. If we shrink it, all of those exterior angles, when we sum them all together, always end up being 360. And I know someone's out there saying, put as many sides as you can in, and we can. We just keep adding, and when we shrink it, in the limitations of the graphics, it still makes a circle. Okay, so when we look at the exterior angles, it's a nice, easy thing to remember. The sum of the exterior angles of any polygon is just 360. Okay, so let's try putting one question into practice here. Again, I like to approach these. There's a couple things I'm going to highlight. When I see these are really important to highlight. That means they are the same length, which means this big triangle here is an isosceles triangle, which means this angle here and this angle here are the same. So noticing those little bits can make a big difference when you go to solve. Everybody will write their certain things through their own certain way, so I like to fill in everything as fast as I can. So I know that's 108. These are 72s. I can take all of that information and bring it down because of my parallel lines and my corresponding angles. And I just like filling it in. And once I have all that information filled in, I find it much easier to keep track of. I'm going to extend this line right here, and I'm going to extend this line right here just to keep my patterns. So I know all of those pieces now up and down that side. Okay, now the problem with this question is getting to the other side because there's no information given. Well, the only way to get to the other side is to know that this is an isosceles triangle and that these two angles are the same. So this has to be a 72, which means this is a 72, which means this is a 72 as well. Okay, and we're just using that corresponding, that F pattern to move all the way up, which means this would be 108. Okay, and now we're left solving for A. We have two angles, and the A, so this would be A equals, A plus 144 equals 180. So angle A has to equal 36 degrees. So if you look, we know A, we know D, and we know C. We've solved for all of our angles. That leaves us with a few questions to try. Thanks for tuning in. Appreciate your time.